An object at rest won't move until something moves it. And an object moving will keep moving until something stops it. That is Newton's first law of motion. Now, the car behind me and the pillar are going to help me demonstrate the second part of Newton's first law. In that last example, the car was our object in motion, and the pillar was the unbalanced force stopping the car from moving. Another part of Newton's law says an object at rest won't move until something moves it. So in this case, the blue barrels are the objects at rest, and the alien is the unbalanced force that will move it. Acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. Now I'm standing right here on this giant tower to help demonstrate Newton's second law for you. Now the object to my right has a small mass and only a small amount of force is needed to accelerate it, like so. Now, the object to my left, on the other hand, has an extremely large mass and is going to need a much larger force to accelerate it. If we could please get a larger force of acceleration on this, please. There we go. And liftoff! Liftoff! There it goes! In that last example, the small thruster was the small amount of force, and the cube was the small mass. The giant tower was the large mass, and the giant thruster was the large amount of force. This is a cake. And no, it's not a lie. It's going to help me demonstrate Newton's third law of motion. Newton's third law of motion states, for every action there is an equal and opposite reaction. In this case, the cake is sitting on the table applying a downward force to it, and the table is applying an upward force onto the cake, which is the equal and opposite reaction. Well, that's all I've got for you. Hope you enjoyed this video, and it's time to go back to the real world.